just having, say, customer purchasing data, the loyalty data for a supermarket
Yeah.
was very powerful because you could now drive recommendation engines or prediction algorithms and feed stock control, a whole bunch of other things. But now let's move that forward. Having the data is useful, but when did you have the data? When did you come to know of this change? That's where the next focus area is, because it's not enough to collect the data. Data is the new oil, and data is the lifeblood of the modern enterprise. All of that good stuff. We know data is important, but there's certain use cases where the timeliness of the data is even more important. That's where you extract the value.
Hello and welcome to That Tech Show with me, Chris Adams, and that fella over there, Sam Gregory. I've been away for a couple of weeks. How are you doing, Sam?
I'm okay. It's been lonely.
Did you miss me?
Yeah, maybe. Yeah, I guess so.
Oh, I forgot to do the thing. What is this show about? Just so we can tell the listener.
Reveals the magic behind the magicians or something?
Oh no, you've messed it up. It's the magicians behind the magic that is the everyday technology. Look, I nailed it first time. I just forgot it. Anyway, so today we're talking to Jamil Ahmed, distinguished engineer from Solace, which is a pretty deep conversation about event-driven architectures. So you didn't really actually get much of a word in here, actually, Sam. So I mean, I've been away for a couple of weeks on the intros where you've led the way, but this one's mainly me, I think.
Yeah, I have no idea about it. I kind of know about it. It's it's every different service is kind of listening in on events and responding to those events rather than fetching them, I guess, maybe.
Well, you'll have to listen in and see what happens.
I should have done that at the time.
Maybe you need a refresh. We'll catch up with you on the outro, see if you learned anything.
Yeah, I'm front end. I'm all front end, so this stuff can be left to you guys.
Yeah, so we talk about his introduction into the event-driven world whilst he was working for the now-defunct Lehman Brothers as well. So we get into some credit crunch excitement here as well, the big recession of 2008. We'll be talking about the environment he was in and around the collapse, and also how event-driven architectures have evolved from the algorithmic trading world to become the default way of doing business for modern real-time organizations that need information now while it's relevant.
Well, if I do remember one thing about this episode, I do remember that Jamil was very excited to be on the show, and that's always nice because you know you're in for a good show when the guest is particularly excited, and it makes us excited, and then we will have a really good, relaxed conversation full of deep insight. So it's pretty cool.
No, I think it's a good one. But while we're actually talking about that, there is one thing I wanted to bring up. So in one of the teams I'm working in at the moment, one of our engineers, she'd been away at a conference and she brought back some exciting stuff to talk about. And so I want to share a little bit of that with you because she was talking about the new stuff that's coming out of the ECMA organization for JavaScript. So this is more in your alley. It's on the front end. Are you familiar with the temporal stuff that's coming in as well?
Nope.
Temporal is pretty cool. So as everybody knows, I think date time in JavaScript has been a complete pain in the ass for pretty much forever, right?
Yep.
So there's a new proposal coming through, which I think should be live. I should have checked this earlier. Should be coming live in, I think, June or July. We're actually just in June, so I guess it's July it's coming. And it is going to now allow you the ability to use temporal.now instead of having to use like the traditional sort of date object or additional libraries like momentum, or not momentum, moment. Yes, and so it's actually pretty clever. There's some nice stuff in there where you can get it to work out instant times, absolutely, intervals. You can get it to do conversions. You can do time zones. It's pretty nice, actually, and much easier to work with because I think every project I've ever worked on, there's always some date time thing, or you're having to battle with a server or something along those lines.
I did actually know about this. You've just reminded me. But what a stupid name, temporal. I've just defined. What does temporal mean?
Time.
Is it?
Yeah. Let's define it. Let's define it.
Why can't it just be time?
Temporal is literally relating to time.
All right. Okay.
So there you go. Now you know. I've learned something for the day.
Very good. Well, with that, I'm currently attending London Tech Week, and it's my second day today. So,
what did you learn from day one?
I learned oh my god! Well, I mean, no shade thrown on them, but it's a bit of bit of a nightmare, to be honest. It's the Queen Elizabeth II Centre in London, and it's not an event space for all the, all on different floors. It's really hard to kind of like mingle with people and all the rest of it. It's a bit of a disaster, to be honest. But and the main headline, I don't know, the main headline stage, no one knew this, but only certain people have access to the main headline stage, which all of the great talks are on. So everyone's just kind of like, what? Waiting outside the main stage for age yesterday for them to say, oh, only a few people are allowed in. So I was like, oh, geez.
Did you get in?
No, of course not. I didn't have the right badge.
Oh, no.
So anyway, yesterday was all about education, a little bit of sustainability. I think sustainability is kind of running throughout, which is quite good. A bit of Web3, a bit of NFT stuff there. And it was education and kind of healthcare was the kind of key topics. And then today it's more heavily on sustainability and another topic, but I'm not too sure. I'm more excited about today and tomorrow than I was of yesterday. But it's been fun. It's been fun mingling and getting to know people and chatting about what they do and what I do. And it's been good. It's been good to be amongst the buzz.
So what are you excited about today, tomorrow?
Today, I mean, it's just the topics. Like I say, it's more sustainability stuff today rather than the education stuff or whatever. So, let's have a look. Let's have a little look at the agenda. Future of crypto is the first one, which I've missed that one. Never mind. That started at 9. Lots of climate stuff today, actually. From blockchain and decentralized economy. That's pretty good. Rise of deep tech in the global startup ecosystem.
Well, the ones that you can get into, you'll have to report back next week and tell us which ones were good.
Yeah, I will do. I mean, there was a couple of good ones yesterday, and of course, went to Jelly Smacks thing as well last night. That was quite fun.
Oh yes, because we have one of the Jelly Smackers on our show in a couple of weeks' time, I guess. A couple of weeks, a few weeks' time.
Yeah, it would be probably August now, but yeah.
All right, so, well, I hope you're ready for this one then, listener. Hold on to your hats as we explore the world of algorithmic trading, events, and real-time data with Jamil.
My name is Jamil Ahmed. I'm a distinguished engineer at Solace. And at Solace, we are on a mission to help enterprises become more real-time and event-driven.
Well, thank you for joining. So event-driven, what do we mean by event-driven?
Sure. So the event-driven is your kind of technical answer to the business imperative, which is to become more real-time. So we can get into a little bit more detail in terms of what that is, and I love your tagline, by the way, for the podcast in terms of the magic behind everyday technology. Mm-hmm. Solace is part of that magic, and we don't have that kind of household name awareness, but we're behind a lot of the household brands that you may be aware of. So I do want to kind of enlighten you a little bit more as we go on here.
Well, we can start with some name drops then. So who are these household brands?
So Barclays, from a kind of bank perspective, is definitely one of those household names. And others, because some of these companies consider what they do with technology as a business differentiator. It's giving them a competitive advantage. We don't have a whole lot who are publicly kind of declaring that they use Solace. But those that do, on the flip side, are very, very vocal. So Barclays is definitely one that we've been public with for a long while. NASA in the States.
Yeah, it's a pretty big one. It's definitely a pretty big one.
I've heard of them.
Yeah, Royal Bank of Canada. We've got Daimler, the owner of Mercedes, again, publicly stating that they use us. So we're actually in that magic across lots of verticals, across lots of different kind of use cases.
So what exactly are they using the product for then? I mean, where does Solace fit in terms of the event-driven world?
Sure. So if we wind ourselves back, a couple of decades, the technology that Solace has been around for a long while, and it would have been known as message-oriented middleware, for example. So within the middleware space, middleware as a category, you could say, is about helping distributed applications kind of communicate with each other, so inter-process communication. in that subset, messaging middleware is quite a niche. And then I would say even my background actually is within low latency messaging middleware, so a niche inside a niche. And my kind of background kind of mirrors quite well where Solace has been as well. So Solace has been powering this kind of low latency messaging need within kind of capital markets investment banking for the most part. And now we're finding that this ability to communicate across devices, across kind of on-prem and cloud, across geographies, that's become a more common need. And if we take the Mercedes example, you've got cars that have now a lot more compute power and sensors than they did, several decades ago. So you've kind of got computers on wheels or data centers on wheels. That all needs the same kind of connectivity, data connectivity, and that's what Solace is enabling.
Right. So are you talking about messaging going as far as sort of IoT then?
That's right. Yeah. So whether it's an IoT sensor that's kind of reporting on your GPS coordinate or humidity settings, it's still a discrete kind of push of data, right? And that fits quite well in this kind of message-oriented paradigm of communication. So a sensor is not pushing data to every single kind of interested party or interested app, but push it once and let that message go to wherever it needs to go, right? So that's how we would have been describing this space, message-oriented middleware. And in the capital market space, you might be thinking of, bankers and Wall Street, but these banks are actually huge software houses. They like to describe themselves as tech companies with a banking license. So these are the entities that have been doing this. And that technology has now become more mainstream. And event-driven, back to your point, event-driven and event-driven architecture is the current way of describing how you organize your data flow, right? And the real-time aspect, which is where this all ties in, is to say, I want to know when a piece of data has been generated or a state has been changed as it happens. That's the event-driven nature of it. And some of your listeners might be thinking of, event-driven, I've heard of that before, right? That's not new. And it's because in GUI development, it's been a concept that was well understood. There's a mouse click event, there's a hover over event, there's various events that are happening across your kind of user interface. I want that to drive some process, some function. And it's because GUIs needed that responsiveness, right? The real-time nature. And I need this to happen as the user does that, right? So this is now taking that event-driven idea of being, uber responsive, very real time, to now how you organize your whole business processes, right? Businesses can now think in terms of being event-driven. So they can be saying, I want to kick off this recommendation engine as the user, say, insert something into the basket, not after the fact. I don't have value from kicking off a recommendation engine if the user has, say, checked out or navigated away already, right? So this is the real-time aspect that more and more industries are looking for, more and more verticals are looking for. And so the same technology that's been doing this within the kind of banking space is now applicable to enable these use cases as well.
So just taking it back a little bit then to just talk a bit more about the origins of this. So, you're talking 20 years ago, you're talking like the enterprise service bus. So I guess the competitors are probably Tibco, BizTalk, those sort of things.
Yes.
But it's actually older than that as a technology stack, right? As an ESB. That's something that comes from 80s and potentially before. Am I right?
Yeah, the concept of distributing data in this way has existed. And you could even say ESBs at their core have a messaging capability. So it's one of those foundational things that is sort of like plumbing, right? Is almost expected to be there. Once it's working well, you don't really care for it. But if it stops working, it's chaos, right? So it's been one of those kind of utility type technologies. And there's been a scale to that as well. So ESBs typically would not have been in the kind of low latency or high volume space, right? And so kind of where Solace differentiated is to say, we're going to take care of that kind of super sophisticated part of that need. And that need was ultimately Wall Street banks competing with each other. It was a race between themselves, and this is where this technology innovation came in, because you could, for the first time, actually put a dollar return on investment on some technology being adopted or put in place, because it was suddenly making you faster than the next bank on the street, right?
This is sort of the origin of algorithmic trading then, I guess.
It's all part of that same space. So high frequency trading, algo trading, this is all in the race for being fastest, right? Being the fastest to act on a market event or the fastest to execute a trade. And this is the space that I began as a graduate, right? So I joined kind of Lehman Brothers as my first postgraduate employer.
Oh wow, classic.
All the way up to the bankruptcy that caused the global financial crash, right? So
wow, yeah.
And from a technology point of view, actually, surprisingly, it was like a huge opportunity for me, regardless of the Lehman Brothers bank going bankrupt. Technology is still technology, right? So the technology platform still had to continue. And when another bank or two banks came along to acquire what remains of Lehman, Barclays Capital and Nomura, they were interested in the technology platform continuing as is, right? So kind of engineers like myself were pretty much for perhaps a 6 weeks period. After that, we were kind of continuing as though nothing happened, because we just had a new bank's name on the building of what we're doing. But essentially, the trading platform, what the offering to the market was, continued as before, because the bulk of that is technologists and technology, right?
So when everyone was being walked out of Lehman Brothers, everyone's carrying their boxes. Were you still at your desk?
Yeah, because that's the kind of business people, right? The bankers who could even say led themselves into that situation. But the technology platform behind it still had value to stay intact and be acquired, right? And so for us, it was, you're right, we were still at desk. We were watching the news of the traders, for example, leaving, but for us, we were still, put on our seats, right? So
that's fascinating. I don't think I've ever heard that side of it before, that, the rest of the company is being walked out of the building and you're still sat at your desk, still doing stuff.
yeah, and this space actually, was very interesting in that, as a technologist in that space, right, you had an acquisition happening of, the Lehman business, and we were in a very kind of strange situation where the middleware platform that was in place, and it was connecting multiple geographies, multiple data centers, all as one kind of uniform mesh. Suddenly you had 4 legal entities involved in terms of where that mesh connects out to, because you had Lehman Brothers in administration for Europe and Americas as a separate legal entity, and you had Barclays Capital who had bought the US side of it, and then Nomura who bought the kind of Europe and Asia side of it. But 4 legal entities connected by a common messaging middleware bus, right? And that's the kind of strangeness of the situation here, because Lehman had done that so well, where everything was globally connected, whether you were deploying an application in London or New York or Tokyo, it all had access to the same kind of data flows. It could push data and be available in another region just as easily. That then became a detriment, because, we can't be having data flowing from these different legal entities, right? So one of my kind of projects that I was involved with almost immediately is, we've got to now disconnect this global connectivity mesh, right? We can't be having this free flow of data anymore, because we need to start snipping out some of the branches to disconnect. And so yeah, being in this space, in this kind of middleware or integration space, having an event like that, which is a business acquisition, and then at the same time we're expanding to be what Lehman was previously, especially from the Nomura perspective, where I was on the Europe side, you have quite a lot of kind of technical challenges, and you're really at the heart of it, because like plumbing, this stuff has to be done well. And you do it once, and then everything else is building on top of that. All of your apps, all of your algos and your trading, etc., does not work if these foundational pieces are not connected and working well.
So what sort of information, what data were you moving around? Is it actually the execution of trades, or is it the responses as a result of the trades, or all and everything in between?
It's pretty much all of the above, really, right? So you had market data as one category of data, which is, what's happening out in the market, what's the price of Apple share, for example, or what's the conversion for sterling to dollar. All of that falls under the category of market data, which is by its nature is wide dissemination. As in, there's multiple parties, multiple systems, multiple human users interested in seeing that. So there's that dissemination of that. And that's market data is actually where you could say messaging middleware began, because of that challenge of broadcast type of data, which is push it once and then it needs to go to whoever has interest, right? So that's the whole paradigm called, publish, subscribe. So one publisher, and then there could be 0 to N subscribers. You're not building yourself in this coupled fashion. You're just pushing once, subscribe as many times as you need. Right?
Was this part of the drive? Because I've read about some of the stuff that was going on within sort of Canary Wharf, et cetera, about the goal of being able to execute the trades as fast as they possibly could, because obviously your algorithm in your algo trading doesn't stand to much if you can't execute it quickly. So was that the goal of some of this event-driven platform?
Yeah, so that's the goal. It was the goal of Lehman, and it's still the goal of some of these major investment banks still in the market, right? So the goal, there's tick to trade is a phrase that you might hear in this space, right? So the tick is the market data that's come in, right, or the change in some state that you need to react to, for your algo needs to react to, and how quickly can it process that and send the trade out to the exchange so that it gets filled, right? So that whole end-to-end flow needs to be super optimized. And roles like myself become this kind of multidisciplinary, you're part network engineer, you're part, Linux sysadmin, you're part software developer. To do that well, you need to actually condense down the whole stack and treat it as one entity to tune, right? And that's really, where the magic has been, right? There's a lot of technical knotty problems being solved in just that space, right? And that's where I've been operating.
And so how fast does a system need to be able to optimize that sort of tick to trade? What sort of time are we talking in, presumably milliseconds?
No, so actually, it can go all the way down to nanosecond latency if you're measuring it.
Really?
And the way you do that is by having your processes even completely cut out the network and OS stack, and then just do shared memory based data copy.
Wow.
Right. So that's one extreme, and your typical kind of high frequency trading algos are operating in that way, right? And they're just what I was describing before of collapsing down the whole stack. Sometimes that means you're eliminating parts of the stack as well, right? So if you're, say, doing any network communication, don't rely on the operating system's TCP/IP stack. Bring that all into app space. That's called kernel bypass. But that's another example of how you're really looking to squeeze out latency wherever it may be costing you.
Wow. So can we expand on that a bit more? Because getting down to nanoseconds, that's fascinating. Because you've got this event-driven system, and we'll talk more about all the event stuff. And I want to go through like how did you split this out of when you went through this migration? But like fundamentally, how do you have an event-driven system that you're stripping out the hardware stack or even the infrastructure, I suppose? How do you have an event-driven system you strip down to get to nanoseconds? Because that's incredible.
Yeah, so all of this is part of a spectrum of latency requirements, right? So at the nanosecond edge is the thinnest part of the wedge. Then you would have other applications that are doing microsecond latency, right? Because they can't be all co-located on the single host because there's a distributed nature to it. Perhaps it's involving humans, for example, getting a request to trade from a client at the end of the phone to be able to then, click some buttons on a GUI and then it does stuff with the algos, right? So there's a spectrum of latency needs, and milliseconds is really where you've got a kind of multi-geo component. So maybe a request for some kind of foreign currency is originating in Tokyo, but then it gets processed in London or New York or wherever, right? So whenever you've got multi-geo and you can't get around the speed of light, right? So there's a certain flow of latency between regions, even though there's a lot of kind of innovative stuff going on to kind of reduce that as well. Across all these different use cases, different kind of latency needs, the one thing that's common is, how do I make all of this complexity easy for app developers, right? Or the algo developer, for example, because you can't imagine kind of low-level detail having that awareness with every single developer or kind of algo developer to be effective at their role, right? So what middleware or technologies like Solace then give you is a simple API to push and receive data, right? So if you need to receive market data, join this kind of solution, and that's going to bring it to you, even if it needs to cross oceans, right? Or it may even be copying across memory on the same server, right? That is abstracted for you, right? And that's where the ownership of middleware is, to make that effective. You could even, nowadays it's described more like a platform, right? This team is responsible for providing you the platform to build apps on, right? And the app developers don't really have to get into the nitty-gritty detail, but somebody has to, right?
I mean, you mentioned about abstracting some of this stuff away from developers. Like, how good do you have to be a developer in somewhere like, Lehman before it dispersed? Or is it abstracted enough that the rest of the system is just fast enough, and as long as you program within a certain window, your application is going to be fast?
If you're in that kind of category of the ultra low latency or the low latency developer, right, you can't get away from having to have knowledge of what the stack looks like underneath the code, right? There's an inevitability there, but the platform can go a long way. So, for example, if once upon a time it would have been low latency development is all in C, but nowadays Java is quite a contender. But to make Java work, you've got zero object collection or garbage generation type solutions that you need to build on. And again, this is one of the kind of tools that Solace would have been given to the developer, right? As in, if you use this API for receiving and sending messages, here's the garbage collection free version of it. If you have to be in Java, or if you can be in C, then you get a lower latency. So it's that wedge, right? You've got to kind of draw the line on how much latency is acceptable and take the complexity to enable that.
Okay, so let's go back to the example you were talking about with Lehman having to deal with that migration. So what technology was the event middleware running at the time? Because this is 2008, I think, is the end of 2008 Lehman went bust?
Yeah, so at the time it was predominantly TIBCO, and TIBCO is one of the vendors that have been disrupted by Solace and others, right? So at the time, as you can imagine, this is a space that moves very, very fast, right? So if you were a relevant vendor for the 90s and 2000s, doesn't mean you're still around for 2010s and 2020s, right? So it's that cutthroat that if another vendor could come along and reduce that latency or make it a little bit more easier to do some of these use cases, then you're in immediately. And that was the kind of very fast moving nature of capital markets IT or high frequency trading IT, because you could take a bet on something that's really up and coming and a very small vendor perhaps and is operating just in this niche, but the latency reduction could give you a business upside that is worth proceeding with, right? And that's why you could kind of move very fast on this. And Solace was one of those disruptive middleware vendors, really. And the way kind of Solace did that is to say, actually, this messaging middleware stuff that's happening in software right now, we've got an idea. We've put all of that logic and baked it into a hardware chip called FPGA. So that was the kind of step change, right? To be able to say, yes, there's a need for this messaging middleware, but you can do better than it being in software. We're going to put it in hardware and completely eliminate the operating system and all the other sources of latency to give you that speed, right? And that became Solace's reason for being.
So let's just come to that in a sec. I mean, the other thing I wanted to get out of this migration, was there an advantage to the fact that you were using TIBCO that allowed you to move quicker than you would if it was some other sort of integration across different geographies?
Yeah, so it helped having a bus like this in place, right? So we don't necessarily have to focus on it being TIBCO. But what Lehman did well was see the value in a messaging middleware kind of construct and do that well to connect everything, all regions. So everything appears as though it's a flat network, whether you're in Tokyo or London or New York, right? And even that alone was a huge win for app developers because they don't really have to worry about how do I access some data that may not be in the same data center as me.
How did you actually deal with it then? Did you end up like sort of replicating parts of the system or just taking bits out of it? I mean, I'm just curious how you break that up into 2 or 3 different entities.
So when it was broken up, there were, you could say, crossing points, right? Where, London was connecting to New York. And it was cleaner in that everything that existed in New York became the Barclays Capital legal entity. So we can't be having any connections to it. So it was mostly a case of snipping those connections, basically. Wherever we see there's pathways that allow data to move from Europe to New York, disconnect those. And then on the flip side, we had the business that took over Lehman had their own middleware solution. So they, again, were bought into the middleware messaging kind of concept, but we're not using the same vendor. So again, from an integration person's point of view, right, how do you get these two things, two disparate technologies talking to each other? Again, there are solutions there, but it was a case of disconnecting on the one hand and reconnecting on the other, right? So this is what I mean, right? The bankruptcy for a person in this space, just in a compressed period of time, gave you so many interesting projects to get under your belt, right? And really see the nitty-gritty of how technology enables something as simple as one business being able to be acquired by another and get going, right? And get going quickly. So
I think I'm probably right in saying that obviously there's a big usage of message buses, etc. TIBCO, etc., and being like the main protagonist, I guess, around this sort of time, 2008. And there's a huge evolution, I guess, over the next almost 15 years, I suppose. Isn't that scary? Over the next 15 years of message-based, event-based communication, especially as microservices start to appear and people start to make use of them more commercially, probably more outside of the banks. So, I mean, talk us through that sort of evolution as people start to take more of an advantage of messages and events. I mean, it becomes a thing in the world.
I think you've hit it on the head, right? Technologies like microservices, adopting cloud, all of those bigger IT trends are kind of forcing a rethink of how does data move from A to B, right? And how do we do that effectively? How do we get an abstraction layer in place such that we don't have to worry about an ever complex IT, right? And so let's unpack this whole messaging to event-driven architecture thing, right? So message-oriented middleware was you could say version 1, right? A message could be anything. A message could represent an order. A message could represent a sensor change. So it was up to the developer to figure out what a message should be for their particular app and their use case. To make that more mainstream, event-driven architecture is now specializing that message, that same message a little bit, to say it's an event, so it's something that's happened. It's a past tense verb, and it represents either order placed or temperature changed or car has braked. It's an event that you can then act on, and this is where the value comes in now, because you're elevating the event from just being this technical concept to now representing business events. It's inherently couched now in business vocabulary for whatever that business is, right? So whether it's order placed representing e-commerce, or something that's in the IoT space, right, that's representing, an elevator has broken down or an escalator has broken down. All of these things are now events that are driving business processes. And that's what's making it the mainstream now, which is the business imperative again, right? I need to be more real time. I need to be more responsive. I need to know as things are happening so I can then act and react. But I can't be thinking in terms of, oh, this field in this database table has changed, or this system has, just changed its kind of internal status, and we've got to poll it to find out what's happened, right? It's this kind of point to point or poll based kind of processing is not going to scale for what's needed in terms of being real time, right? And that's the journey that Solace is now enabling, to be able to say, we've done the thin edge of the wedge, right, to be able to do low latency. We know how to do that well, and we also know how to do scale. So whether it's Mercedes coming in and saying we want to have 20 million cars on the continent connected as an IoT device, to we want low latency, the whole spectrum of being able to move data, right? Solace has done that, is kind of battle hardened from that specialist space that I was describing, right, with like high frequency trading and capital markets in general. And now we're able to say this technology can now be applied for, say, disseminating aerospace data, right? So where are your flights? So, the GPS coordinate of each flight in the US airspace, for example, is something that's flowing across Solace technology. And it's very different from what I was describing before in terms of trading. But the need to move data, the need to move that reliably in a timely manner is really what's differentiating here.
And so, the events that we're talking about are, you're probably talking millions more events than the sort of stuff that we're talking about around the time that you were working at Lehman, I guess, because we're talking about IoT and all those sort of things now.
Yes. So there's still a lot of events actually in the kind of trading space. One of our vocal customers, Royal Bank of Canada, has put out that across their mesh, they've passed in excess of 100 billion events a day.
Wow.
Right. And that's a global mesh with all the kind of trading zones like London, New York, Toronto, etc. So it gives you an example of the scale achievable. So if you then extend that same technology to get sensor events or events of kind of coming out of microservices or generated from cloud native services, it doesn't really matter what the volume of that is, because we have a scalable architecture to kind of address that, right? What we're focusing more on nowadays is this ability to have a fairly abstracted layer of passing data is hard to get your head around, because developers, for the most part, are used to things like calling an API to get data, right? If I call for this information, I'm going to get it, then I'm going to act on it. You turn that around by saying it's an event that's going to be pushed to you as it happens, right? And that brings about multiple challenges, right? As in, how do I scale my solution, because I am no longer in control of the rate at which it's going to be arriving at. I need to be scalable to the real world out there, right? So that ties into things like I need to be deployed on an elastically scaling architecture, like Kubernetes in the cloud. All of those things kind of come into that. Or you could even say, actually, I need some sort of a shock absorber capability. I need to be able to consume all the events, but I want something to slow it down and meter it out to the ability that I have to consume. So again,
and that's the advantage of having a queue then.
Yeah, so that kind of queuing or buffering capability is what you'd expect to get from such an event mesh, right?
So you've said mesh on a couple of occasions. We talked about like buses as well. So obviously there's a couple of different ways you can go about implementing microservices. You could go for a point-to-point integration, generally not my preferred approach. You could go for a message bus based integration, a pub sub type thing. But you could also go for a service mesh as well. But you seem to be mixing those two terms. I think mesh and pub sub.
Yeah, so there's been a little bit of a terminology evolution, right? So just the same way enterprises at one point would have been caring about just the enterprise, but now that's diluted to say it's enterprise and whatever cloud we're using, right? Or security concerns are now, cyber security. So messaging middleware has similarly undergone this kind of evolution to say it's not enough or descriptive enough to describe it as messaging middleware. It's an event mesh of event brokers. So your message queue, your message bus that you were describing before, all of that is now kind of encapsulated under what's described as event mesh. And it's something that Solace coined as a term, as a description of this architectural pattern. But we did it in such a way that we didn't want to own it. And accordingly, we've got other vendors like Red Hat also adopting it to say, oh, we've got an event mesh solution as well. So to kind of carry you forward, right? If you're definitely familiar with messaging and message bus and ESBs, it's just part of that natural evolution to now land at event mesh and event brokers today.
Okay, so imagine for my sake, I'm out of date by probably a few years, I guess. We've got Kafka, say something like that, as an event backbone. How does that change when I'm using an event mesh?
It doesn't have to. So you could actually even have Kafka in use today to power, for example, your kind of big data solution. But that needs input and output as well, right? So there may be something that's happening in the rest of the enterprise, or maybe another part of your kind of use of cloud that needs to feed into your big data cluster. So again, event mesh could be what's carrying those changes, those new events into your Kafka cluster, and anything that's happening in the Kafka cluster needs to come back out to touch anything else. Likewise, it could be traveling over the event mesh. So it's very complementary. And you typically use Kafka for where it fits best, right? And what is it designed for? Let's ask that question. Log aggregation, being able to do that at speed. That's where that was born, right? And then there's Solace technology that's born in this kind of moving at low latency, high fan out, pub sub manner. And if you need queuing capability, there's queuing as well. So they're similar in that they're in the same space of middleware, but they approach two different markets in a way. One was born out of this log aggregation need, and Solace was more of this generic, any use case, data is data type space.
So Solace is behaving in a way that allows you to get that data in more easily, then, is what you're saying?
Yeah, so you could have your Kafka installation be just another component on and off the event mesh, right? So everything, so if we kind of rethink integration as no longer point to point or calling system A, calling system B, you're integrating around the event itself. The event is your contract in terms of what am I producing? What's it going to look like? And then what do I need to consume and what does it look like? You don't really care about the end system anymore. So in that vein, right, you could be consuming an event that originated in a Kafka-based system, or likewise, pushing something that ends up in a Kafka-based system. The event mesh or the Solace kind of product here is to say, elevate yourself above all of that complexity to just have a mesh that you come on and off. It's on-ramp to a mesh and off-ramp to a mesh. You don't really need to think about the plumbing in between. Let us take care of that.
So I suppose how does that simplify, say, if I want to build an app on the front of that? Because I guess, figuring out how you're going to have a client-side app that integrates with a message queue like Kafka is pretty complicated, because you can choose a couple of different solutions. You could go for, I'm going to have an API that is just going to give me sort of access to a service that is connected to the queue, or I might have an API that is going to put a message on the queue and wait for a response, which may not be a great idea because I might be waiting for a very long time. Or you might have a WebSocket or something along that sort of lines that's giving you some sort of real-time interaction with the queue. So there's a couple of different ways I could do that. How does Solace behave in that scenario?
So Solace gives you, multiple protocol ways of connecting. So you mentioned WebSocket, you mentioned, having awareness it's a queue. The other protocols, such as JMS as an interface to connect in. So think of Solace as this kind of Swiss Army knife of multiple protocols to fit whatever your use case needs. So if you had an application that's kind of running in the browser and needs this fast bidirectional connectivity, it can have a WebSocket connection to the Solace broker to say, here's the messages I'm interested in, or here's the events I'm interested in. As soon as they arrive, trigger this callback, and then it's going to trigger this onward processing. And likewise, push data as it gets generated. So if a user in the e-commerce space is, navigating a website, added a item to basket, that's an event that gets pushed through the WebSocket connection to the event mesh, or the event mesh is a network of event brokers. So if you push it onto the mesh, and then anything else out there, which could be your back-end systems, will be connected to the event mesh to consume what got pushed by the browser, right? So you can think of the data or the events flowing to wherever they need to and fit the use case with the protocol. It's not a choice that you're forced into, right? So you could have WebSocket. You could even actually have a HTTP RESTful interface to be able to say, this event that I'm producing, I'm actually going to do a post, HTTP post into the event mesh. And that's going to turn into something that may sit on a queue for a subscriber that wants that guaranteed delivery nature, to be able to say, whatever gets generated, keep it in the queue until I actively take it off, because the value that I'm deriving from it is from having the full sequence, for example, without any loss.
So if I was doing something like this with Kafka as a raw implementation, I would be having to build a lot of that stuff myself. Is Solace taking care of some of that?
Yeah, for the most part, if you did say have a mixed mode of, say, WebSockets and needing to do REST or even MQTT for a device sensor, you could do it with Kafka, but you're bolting on quite a lot of components to support that, right?
Yeah, you're adding services, or you're finding other integration things that integrate into something like that.
Yeah. So this is what I mean in that you can do it with Kafka, but it's a lot simpler to say do it with Solace, because all of that is just part of the offering, right? So that's the distinction, right? In that, yes, if you're familiar with Kafka and you can't get away from it for that particular use case, treat it as yet another publisher or subscriber on the event mesh, right? And then you're kind of hooking it up to everything else that might be happening. And that event mesh could be extending out to an AWS region, for example, or a Google Cloud region or Azure region. And that mixture of, I don't want to deal with the complexity out there, I just want to push and receive data, is what you're getting here.
Okay, so let's go into some of that stuff that you'd teased us with earlier in the conversation. You talked about hardware chips and all that sort of nonsense. So what is that nonsense? Unpack that for me. What's the hardware chip that Solace created?
So in this crowded space of messaging middleware already existing, right, we had to differentiate, what could we do to knock out the incumbent? And knowing that actually running this function in software means you're building a lot of the engineering around it. How do I make it resilient? How do I give it disaster recovery across multiple data centers, right? There's a lot of engineering that's happening to make what's seemingly simple software that kind of battle hardened, ready for the kind of whatever the market throws at it, right? So Solace saw this as an opportunity to say, that doesn't need to be in software anymore. It could be baked in with technology called, field programmable gate arrays, FPGAs, essentially putting logic on hardware so that you don't have to execute it through a CPU, in a general purpose CPU. And that gives you the latency saving. to be able to say this chip only does this function, right? It's not a general purpose CPU. Therefore, it can do it optimized for speed and high throughput as well, right? So, in this kind of space, you're talking about needing to push millions of messages a second, for example. So where Solace began is a device that you can kind of turnkey rack into your data center, and it gives you your messaging capability with network optimization, with OS optimization, all that stuff that you would have been building, all as just one piece. And that is, still the biggest differentiating, that there's nobody else on the market that can give you this, right? And even outside of banking, it has a pull, because there are certain, say, security conscious industries that kind of get comfort from this hardware approach, because it's a much reduced attack vector for security. You're not having to worry about all the layers, right? What's my switch? What's the operating system? What's the patch level? All of that is just treated as one black box.
So how does that work in a modern sort of cloud-driven environment? I mean, how do you get access to that stuff?
Very good question. So that reflects the evolution of where Solace went next, right? So we started with this hardware, and then of course you have to address the need to deploy in virtualized environments or in a cloud. So that turnkey approach lends itself quite well in this new world of containers. We can give you a container that represents your messaging capability or your event broker capability. Looks and feels just as what it may do with the appliance if you had the appliance, but now you've got it in software, and then all the flexibility of being able to do a Docker Hub pull, and it's running on your laptop.
But there's got to be a performance difference, right, between the two?
Of course, yeah. So, and that's why I keep going back to the latency spectrum, right? Depending on where you draw the line of how much latency penalty is acceptable, whether you're counting in milliseconds, microseconds, or nanoseconds, right? That's where you use the right form factor. But this kind of hardware space isn't for everybody, right? Because not everybody cares about the nanosecond or microsecond latency, but they do care about stability. They care about being able to handle spiky volume. Like suddenly you had an event like a new product release, and your website's crashed because you can't cope with the inbound order rate, right? All of those things are then important. So what do? The software version can handle those use cases. It's opened up a completely new segment of the market, right? To say, I don't care about latency, but I care about scale and stability and general burst absorption capability. And that then has, a huge play in e-commerce, for example, especially for some of the brands that may spring to mind that have this bursty nature, as in a product release has just become available and you've got queues of people, and likewise queues of people hammering their website. How do you deal with that sudden spike in inbound? So you put a technology like Solace in place to give you that shock absorption and the guaranteed delivery, to be able to say each of those orders is important. We can't afford to lose them. We can't afford to time it out or drop on the floor for whatever reason, right? We need to collect all of them and scale up, maybe through the magic of Kubernetes and other elastic scaling solutions, to meet that demand that's sitting in that queue now. So we scale up, deal with the backlog, and then we scale back down again. Those scale out, scale in kind of solutions can only work if you're taking care of the data delivery side of it as well. Right. So this is how Solace is very complementary to some of these other new developments.
So how do you sort of stick with that exactly once delivery then? How do you guarantee that message delivery? Because that's tricky, right?
It is, and you've definitely been in this space if you're asking that question, right?
I've learned the hard way, yeah.
No, that's an age-old problem, right? How do you guarantee once and only once delivery, especially when it is a guaranteed mode? So there's certain tricks that the event mesh or the event broker can do, right? So if it can track the fact that I've tried to deliver this and I didn't get acknowledged, something went wrong. So as part of delivering it to the next connected consumer, you can just do a simple flag on there to say this is a possible retransmit, this is a possible dupe, right? So that can then trigger code on the receiving side to say, okay, I need to do some extra processing on this to make sure that I haven't already inserted this into the database, for example, right? So you need your solution, messaging middleware solution or event broker solution, to give you those hooks, those signals in the API that you use, right? That's part of the contract. How do I do this effectively and safeguard myself, right? So that's definitely one that's kind of been addressed.
Well, I think there's a few ways of working around it as well, right? Because I mean, the last time I did an implementation like this, we actually built all of the consuming services to be able to handle duplicate data, so that they wouldn't. Well, they would just deal with, I suppose, more of an upsert model in the sort of Cassandra sense that, like, if we've not seen this data before, we insert it. If we have seen this data before, then we update it, so that you're actually catering for the fact that in an event-driven system, you are likely to have duplication, or if someone's uploading a file, they're likely to do it several times because you're catering for humans.
Yeah, so that's exactly it. In that you when you move to this mode of data movement, right? It's all asynchronous. It's kind of intermediated by a broker. You need to start coding defensively in that way, right? As in, could I have received it? What's the flag to tell me if I did? What else can I do, right, to protect myself? So yeah, exactly. And this is part of some of the enablement that we have to do to the market out there, right? Which is, not everybody has had that luxury of knowing messaging middleware in the past. A lot of the companies that we work with today, for example, don't have that legacy, ESB data center type mentality. Think of your kind of car manufacturer. They've suddenly gone from just manufacturing cars to now having to think about IT and code and services.
Well, yeah, the software companies now, and that's a big jump for them.
And that leapfrog advantage that they have is of no legacy debt to carry, gives them the flexibility to look at solutions in a way that a bit purer, right? As in, I can look at this without being distracted by some of the gotchas of the past, because those gotchas may no longer be valid, right? They may be something that a vendor that's no longer around put out there as a problem in the market. But if you've been burnt once, you remember it, right? Some of these enterprises that we work with are able to just trust the fact that, okay, this is the recent evolution of the technology that's dealt with a lot of these common problems.
Does the platform come with an instruction manual then to sort of bring everybody up to speed with these things?
There's a lot of kind of material out there in terms of our documentation, our community site. We also have free certification. So if someone was really looking to pick up, even from a event-driven perspective, I want to know what event-driven architecture is. How do I build apps? How do I organize my business around it? We have free certification that teach you just that, right? And that's kind of product agnostic. It doesn't really care if you're using Solace or not, because it's that different style of thinking, right? Accepting asynchronous updates, accepting the fact that I'm intermediated from my end system. In fact, that's an advantage. I don't want to know if my downstream is up or not, because I want to keep on going regardless. That's, for some use cases, some enterprises, this is radical thinking, right?
I think it is for most people. It is really a different paradigm as soon as you start working in events.
Yeah, and it's because as developers, we're not taught in that way from the get-go, right? It's all about functions and sequential flow of things and calling out for data, and so it does need that kind of mind shift. So a lot of what we do as part of some of our engagements is nothing to do with product or technology yet. We want to do this enablement of, here's a better way of organizing your services, your microservices, the functions that you're calling out to your cloud provider. It doesn't have to all be point to point, right? And a lot of the times that's the MVP, right? That's what's been put in place to see if the solution has legs. But then you hit the scalability bottleneck, that then kind of you come back to the drawing board. Okay, how do we do this better? And that's when you start thinking of asynchronous communications, publish, subscribe, kind of pattern intermediation of systems, right? And that's what we're enabling.
So let's just talk a bit about the IoT side of things, because I think that's pretty fascinating. So, we've talked about NASA, Mercedes. I think, both of those are going to be companies that are going to have a lot of IoT stuff going on. In fact, I know NASA would have had IoT essentially before IoT was a thing. At least they would have had a lot of sensors and things that would be reporting back for the status during a space shuttle launch or something along those sort of lines. Because I don't know how they would even get that. I presume it's probably radio frequency that they'd be reporting back. That's me guessing, but you might be able to enlighten me. And then obviously from the Mercedes side of things, you now have these computers on wheels, as you mentioned at the start of the show, reporting back a hell of a lot of data. How do we deal with the accuracy of the data that's coming back? And, how do you ensure connectivity to make sure that they can actually connect into the event mesh and get the data where it's supposed to be?
So those are the challenges that we expect the user to kind of hand off to the event mesh, right? And so those are acceptable kind of requirements, and we feel they should be part of the responsibility of what the event mesh gives you, right? So take the example of how do I make sure I'm connected, or how do I make sure the data is current? That's an important part of event-driven architecture, in that you've got to be able to act on the data that you receive, knowing that it is the most latest version, for example, or is there any kind of risk of it being stale? So IoT pushes that as a requirement right to the top, because say Unilever is another good example of a user where they've publicly blogged about their virtual ocean control tower. They want to approach goods moving across oceans on ships with the same kind of tracking granularity as aircraft in the skies.
That's interesting. When you were saying Unilever, I was trying to think, where is this going to go? We haven't connected Marmite. I don't understand, but makes an awful lot more sense to be tracking ships. So
yeah, so they have taken this to the level that where is a particular line item from a manifest? What ship is it on, and where is it on the ocean at large, right? So when you had crises like the Suez Canal blockage, right, you had companies that knew exactly what their impact is and move on to mitigation plans, and you had other companies who didn't know they were impacted until something further down the line was failing, right, or failed to arrive. So this is the shift you can take, event-driven architecture, or more business speak, real-time communication, right? Real-time business operations, knowing exactly where things are. So if you've got, a GPS sensor telling you your location, and that's coming to you, or you're checking it 10 minutes late, right? That position would have moved on by several knots at speed, right? It's not actionable. It doesn't tell you anything. With the Suez example, you don't know, did it just make it past the blockade, or is it still behind, right? It's not actionable data. It's not something that even if you put onto a live dashboard, you can't do anything with it. You can't drive the business kind of fallback measures, for example, right? So IoT and what's kind of event driven, what's moving across an event mesh, this latency part of it that felt like it was just a niche, right? It's just the high frequency trading guys care about. Now you see this kind of wider applicability, that as in, I need to know that this thing that's arrived, this piece of data, isn't stale by seconds and minutes and hours. And you didn't have that ability before moving to this kind of paradigm, right? Because you could be, say, doing an API call to poll for a change, but you can't run that continuously in the loop, right? You'd get in trouble because the service owner or whoever's on the other side will start complaining, you're hammering my resource allocation because you're constantly asking for the same thing and nothing's changed, go away, right? But moving to this kind of push-based model, you're getting a push as the state changed, right? And you're getting a reliability factor in terms of how that hopped across, perhaps multiple brokers to get to you, but it's the most recent version of that, or the latency isn't going to be, making it stale and unactionable, right? So a lot of what event-driven architecture is looking to achieve, and why you'd want to even adopt this kind of solution, is where you can drive business processes that you may not have even thought of before. Like you couldn't even consider it because you didn't have the data to hand, right? And on a kind of previous episode, you mentioned how just having, say, customer purchasing data, the loyalty data for a supermarket was very powerful because you can now drive recommendation engines or prediction algorithms and feed stock control, a whole bunch of other things. But now let's move that forward. Having the data is useful, but when did you have the data? When did you come to know of this change? That's where the next focus area is, because it's not enough to collect the data. Data is the new oil, and data is the lifeblood of the modern enterprise. All of that good stuff. We know data is important, but there's certain use cases where the timeliness of the data is even more important. That's where you extract the value. And in the extreme sense, more time that goes by since that data was available and you fail to act on it, the less useful it becomes, right? So there's this imperative to kind of really act on it as soon as it arrived. And those are the kind of use cases that event-driven architecture is driving, and that we at Solace are very excited to be part of, really.
So how do you ensure that connectivity though? Presumably it's not just for the IoT stuff, because there is definitely good examples of the NASA stuff. There's the Mercedes stuff. I can imagine Formula One based examples as well. There's a lot of data that's being collected that it's imperative that it's fast in the same sense as it is for the stock market. How do you ensure that connectivity? Because presumably it's not just traditional IP stuff. Is that where we're getting into the radio towers and things like that, microwaves and stuff?
So if you consider the kind of stack of technology, right? You've got apps on top, you've got your networking protocols, TCP IP, then you've got physical links, right? Whether it's Ethernet or Wi-Fi or radio. So we are operating above those, right? So connectivity, to say how do you make sure it's connected, a car could be connected by a 5G SIM, for example, or picking up some sort of wireless mesh that's kind of citywide. So that detail is one layer below kind of what we do, right?
So you're not really getting into the firmware or along those sort of, or are you getting into the firmware of these IoT devices?
No, so we're operating at the close to the application layer, but with the expectation that the protocol is dealing with some of the challenges, such as a blip in connectivity. If an IoT sensor was connected and then it went into a tunnel and it came back out the other side, what data was meant to go to it and what data was meant to be pushed from it? How do you handle that pause, that break? How do you kind of recover the stream? That's happening at layers above in the protocol, right? So MQTT, for example, is a popular protocol in this Internet of Things space. So we let the protocol do that well, and then we are just another technology that supports that protocol.
To provide that integration to get it to where it should be, to then allow you to make the decisions, yeah.
Yeah, so we give you the API that allows you to do that simplified send and receive, and there's a lot of stuff happening underneath, of course.
Okay, well, I mean, I think this has been a really insightful conversation. Have we left anything out?
Well, we've been bouncing around all these different use cases and verticals, right? But as you can imagine, it's the movement of data is really what's key, right? That's what's powering some of these functions, especially some, like new product offerings. Like if, for example, your airline, as part of your check-in process, could know exactly where you were and how you're progressing to the gate and where you are in the airport. Product opportunities like giving you a push notification to say, oh, here's a new 20% off voucher for this restaurant in that part of the terminal, because it knows you're nearby, right? Some of those kind of business innovation, you couldn't even imagine implementing a decade ago, right? Because the data wasn't there. And then even if the data was there, it wasn't timely. Like the loyalty card example. Yes, we could know that, what the purchasing history was, but if we're only getting that crunched and it takes 3 months before we can get value out of it, maybe the situation for the consumer has changed already, right? So this movement towards real time cuts across multiple businesses and is really an exciting place to be as a technologist.
Yeah, I think that loyalty example you're talking about, for the listeners listening in, I think we mentioned this on a previous episode that I was probably a decade ago when I was at Tesco. We had all the club card data, and the club card data was generally about 3 months out of date because it would arrive as sort of a big batch of receipts that had to be processed by a subsidiary company called dunnhumby. And then it would all arrive, you'd get like your reports after it had all been typed up 3 months later. And then equally, we used to have an issue where your trucks would arrive at a store and it may or may not have the cages on it with all of the products that we needed to like refill and restock the shelves. That's a big shift in a decade from where that was to what you're talking about us being able to do now. Of actually, I think this is where people have wanted to go for a long time. It's where technologists have wanted to go, because there used to, the RFID chips and stuff. There was some examples probably a decade ago of people experimenting and trying to get stuff to work in prototypes on Regent Street. You'd walk past a window and it would go, oh, here's an offer on this particular shop. I remember seeing Burberry doing something along those sort of lines, but it's all prototype stuff. Now, what you're talking about is we're on the cusp, or it's actually here. We're actually able to do this.
Exactly. We're actually here, and that disconnected nature that you're describing in that past episode about, why is it that the store manager's tablet, why can't it tell him what's going to be on the truck, right? It's because there was, you can imagine a whole series of batch operations, right? There's probably an overnight batch that decided what's going to be filling that lorry, right, or that truck. There's another batch operation that's dealing with the order request that the store managers have made, and they're just not connected, right? They're not kind of seamlessly operating as one. That's what event-driven architecture hopes to kind of achieve, which is everything's an event. And it's not trapped in these data silos. Like, it's not trapped in the mainframe. It's not trapped in the shipping function. It's not trapped in the stock control function. It's just an event accessible to whatever part of the business wants to derive value from it, right? And that's how you can start thinking about how, if I know a customer is doing X at the store, I want to be able to derive this new product opportunity or this recommendation text, right? Or push something to their email or a coupon. The connectedness of data is really what's powering those new business functions, right? And event-driven architecture, we definitely need to see it more than just this technical term, especially for those who are familiar with it. It's really taking the responsiveness that you get when you're building event-driven UIs to now organizing your whole business in that responsive manner, right? There's no reason why the stock control function cannot be tied into recall management, to customer loyalty, to what's being loaded into vans and so on, right? Or even now beyond the e-commerce side of the business, right? Everything has to be working as one. And that's where you get event-driven architecture as being that magic behind the scenes.
You've managed to get in the tagline there. Nice. So this is here now. This event technology is here now, and we can start using it, and we're going to see more of it over the next few years. But where's it going next?
Where's it going next? I think is definitely going to touch the average consumer a lot more. You're going to realize some of these things are happening. And one of the most recent things that we can talk about is the UK's energy regulator, Ofgem, wanting to move to how energy billing is done to a half-hourly basis, right? They want to move from what's currently a daily basis, or in some utilities such as water is even worse, right? You get a bill at the end of 6 months to say this is how much water you used. That's now compressing things down again to close to real time, not quite, but still going from 24 hours to a half an hour chunks is still a leapfrog change. To arm you as a consumer with insight. Where am I using my energy? What part of the day? And likewise, with the example of driving new product offerings that we can't even imagine, there's no reason why once that data is available, you can't get tariffs that are smarter to be able to say, here's your unit price for this part of the day, and here's the unit price for that part of the day. And that's going to be different again tomorrow based on what the market conditions are, right? So you can be a lot more targeted around how you use your energy, how you kind of benefit from the natural peaks and troughs that are happening in the market for the price of energy, to apply it in your own home, to be able to say, okay, so it seems like things are a bit higher, so I'm not going to switch that washing machine on now. Oh, it's dropped again the next hour. I'm going to switch it on now, right? So it's that kind of nudge economics, right? It's not going, the regulator is not forcing everybody to use less energy, but just by nudging you to even be aware of what you're using at the right granularity makes it a bit more actionable. And that's the theory of going towards, reduced energy usage.
God, I really hope that helps to benefit the consumer and not the not the supplier, because it does sound like that could be used for evil.
Yeah, and it's just an example of how having more data, more actionable data, can then drive value and hopefully human betterment, human good as well.
Well, yeah, and we've talked on other episodes as well about that sort of democratization of data and energy, and hopefully it's the sort of thing that's going to be able to power that. Because you wouldn't want to have that sort of stuff. You wouldn't want surge pricing for running a bath, would you? Like get on Uber. I can imagine that.
Well, we hope it doesn't go that way, right? But yeah, democratization of data, democratization of access to services. This is all in keeping with what an event mesh does for you, right? Because now your data is no longer locked in a particular system. It's just something that I can tap into on the event mesh. It's like switching on the tap and then the water starts flowing, right? I don't really care where the water was pumped from. I have a need for it and it's flowing. You can think of events in the same way, in that here's a specific event I'm looking for. I don't care who's putting it out there, right? I'm going to consume it and then I'm going to maybe put out another event of my own. And this whole daisy chain of events is what's then all of your microservices. That's your enterprise's IT.
Yeah, it's powerful stuff if people can get their head around it properly. Any final thoughts?
Just the fact that it's a great podcast that you have here, and I think techies talking about some of the magic is definitely useful, and we can very often operate in silos and not realize that things like an event mesh even exist, right? And that's really what we're trying to do here, right? Which is know that it's there, and then maybe it can solve my problem.
Well, thanks, Jamil. I mean, I wasn't fishing for a compliment, but but thank you for joining us on the show. I've really enjoyed this discussion, and I hope our listeners have.
Nice to be here. Thanks, guys.
Well, that was a nice little compliment from Jamil there. It's nice to have someone on the show who's actually been listening, and so I
been listening.
Yeah, before the show, and I actually enjoyed it. It was pretty cool.
Second listen, Sam. Did you catch any more of that this time round?
Nope.
Brilliant. Okay, well, we'll need a third time round. Maybe you go back to the Fred George microservices one now.
Well, we'll go back to finger puppets and try and demonstrate what event-driven architecture is.
Anyway, listener, if you've also struggled as Sam has, then we may be taking some time, if we ever find it, to put together a finger puppet show on event-driven architectures. We'll see if that happens.
I think that's it. That's the one.
Okay. Well, join us next week for Neil Parker, who will be talking to us about IA. That's right, IA, not AI. IA stands for Intelligent Automation, which will be the topic of next week's show.
We'll see you next week. So here we go. As usual, do give us a 5-star review on Apple and Podchaser.
We've had a few more of them.
Ooh, you've been listening. Thank you so much, dear listener. And of course, like us wherever you see us post on social media. We've revitalized the Instagram now, so you should see the episodes trickling in. And actually, it's been nice doing those, because it's like, yeah, I remember that one, I remember this one, and people are actually thinking, oh, that sounds pretty good. I should listen to that one. So it's been nice.
I actually had someone reach out to me this week and say, "Oh, this new episode looks really good." I went, "Hang on a minute, that's from a few months ago." Sam must have kick-started the the Instagram again.
I'm trying to post like 3 times a day to try and get us up to speed before Thursday, but I've always let it slack a little bit. But yeah, so I post a little story about my thoughts on the episode, and then just post on our wall. Is it a wall? I don't know. Our feed. post on our feed as if it was a live episode. But yeah, people have been engaging and reminded of or introduced for the first time some of our back catalogue. So that's been quite fun. We should do that more, actually. We should do that.
We should do. Yeah, we should do, because we've got some great content. We were just reflecting how we've probably recorded about 70 odd hours of content. So plenty of tech stuff out there for you folks. So yeah, check in if you have any recommendations, comments, or thoughts. You can drop us a line via the website. I think there's an email address on there somewhere to hello@thattech.show, I believe.
Yes, and a contact form as well, so you don't have to write an email.
You don't even have to. Yeah, you don't even have to do that. Yeah,
don't have to lift a finger.
All right. Well, that's it. I think we'll see you next week when we are joined by Neil Parker.